today. I think the previous session was actually an interesting introduction because I would like to focus exactly on everything that's going on inside the DCS and all these OT operations and how we can maintain the separation and security of these OT operations while still having the data that's being generated, that good digital data, the good analysis, and bring it out to the enterprise side and doing so safely. I'll make one other comment before I start. I have my video on now, but I am from home. I have one son here on Minecraft, another son on Spotify. So if the bandwidth starts to get poor and you can't hear me properly, I'll turn off my video. So please let me know if that's the case.
Surely, sir.
So just quickly about my company. So my company's name is Waterfall Security. I'm a sales director in charge of parts of Asia, including India. We were founded in 2007. We're based in Israel. We have offices around the world, including here in Israel, USA, in Europe, in Abu Dhabi, as well as in Singapore. We are exploring, perhaps within next year, opening an office as well in India and in Korea. We have installations in thousands of different industrial sites all around the world. And if we think about power specifically, power is definitely Waterfall's #1 vertical. The company was started with the focus on power generation, nuclear and conventional power generation. In the United States, in Japan, in Singapore, in Israel, in many other countries, well over 50 to 60% of the power sites in each of those countries that I mentioned are using Waterfall security technology to protect their sites. In India, we do have several customers today. Some of these were brought to us through our global OEM partnerships. So sadly, I'm not able to mention any of the specific end user names, but if we want to discuss, anyone's interested to discuss offline, I can mention a few references. So as I mentioned before, our topic today is industrial cybersecurity, and our challenge is really this OT IT problem that has been the focus and the challenge of many power generation companies for many, many years. Of course, we have all the great digital data that's being generated on the OT side. Some of the sites that exist out in the world today, and in India, I know, have been around for so long. They were never built with the internet in mind. They were never built with cybersecurity from the internet as a core issue to make sure that we overcome. The digital data that's being generated on the OT side is giving us monitoring capabilities, giving us visibility to the business side. It's giving us predictive maintenance, like we heard before. And we really need that data to come out from the OT to the IT side, to the corporate enterprise side, so that we can maintain business continuity. And of course, once we are connecting the OT network to the IT network, we are exposing the OT network to the enterprise with the internet. Now, of course, we are exposing the OT to all these potential cyber attacks. So how do we maintain these two challenges together? How do we maintain the continuity of our business, the visibility of the OT network, while still giving absolute protection of the OT network for the internet-based attacks? This is our challenge. This is what we are trying to accomplish here. So when we talk about industrial cybersecurity, we'd like to break it down to 3 important rules that we must follow, and from there, we'll try and develop our solution. Rule #1 that we need to always keep in mind is there's no such thing as 100% industrial cybersecurity. It's just not possible. It's a myth. If any vendor, if any consultant comes and tells you, all you need to do is X, Y, Z, install this product, install this tool, then you are protected. It's just a lie. It's not possible. There are so many ways an attacker can come to the network, external and internal and human-based attacks, etc. There are so many things that they are trying to do. You cannot simply implement one technology, one strategy, one tool and say, now I am complete, now I'm covered. I don't need this tool or that tool or my cyber team. So we must always be vigilant, and we must have many, many layers of cybersecurity protection. Rule #2 is that anything that is software-based is inherently hackable. We cannot rely purely on software tools. Human beings write code, human beings make mistakes, there are bugs in code. If we are relying purely on code written by human beings with bugs, we know we will be attacked. The attackers today are smart enough to analyze those software tools, find the holes, and leverage them into their own cyber attacks. So we know this to be true. Any attack you've ever read about has been the penetration of a firewall. And at the end of the day, that's all a firewall is. It's a software tool. We think about it as hardware because it's sitting there on that server, but at the end of the day, it's software. You look at the websites of Check Point and Cisco and Fortinet and all the leading industrial firewall vendors, they list on their website their known vulnerabilities. They list on their website the things that they are aware of, the bugs they're aware of, and the patches that they're constantly putting out. And this doesn't even cover the zero-day attacks that they themselves haven't become aware of yet. So we know we cannot rely purely on software. And rule number 3 is that anything that is, anytime there is an attack, it's because a piece of information has come into your network that should not have been there in the first place. That's what the attack is. It's something penetrated into your network, which is the ransomware, the virus, whatever it is, something came into your network. And if we are relying on firewalls, which at the end of the day are software-based networking tools, which are doing bi-directional communication, which are bringing data back and forth with TCP/IP acknowledgements, then we are essentially opening the door to our attackers. We actually do at Waterfall an entire presentation simply pointing out some of the inherent problems that exist within firewalls. Because at the end of the day, as I mentioned, firewalls are routers, they're network forwarding tools. That's what they're doing. They're taking messages from A, sending it to B, and getting an acknowledgement back to A. And it doesn't take a very sophisticated attacker to leverage on top of those TCP/IP channels and push his attack in. And there are many, many different ways that an attacker can not only overcome a firewall, but actually leverage the firewall and use it as his method of attack. So we're not saying that firewalls don't have their place. Of course they do. They are a core component of the overall security architecture and all the tools that we're trying to implement, network segmentation, etc. It's what essentially the IT security tools are based on and built on, and that's the foundation. But things like intrusion detection and updates and patches, these are all IT methodologies and IT processes which aren't actually designed from the ICS perspective. They're not designed to protect the OT, the DCS, the SCADA. And those networks, everything that exists over there, they were never designed with security first in mind. You think about a PLC. A PLC was never designed with security as its focus. How many PLCs exist today which have encryption on them, which are actually talking to the HMI with encryption to make sure that someone can't leverage an HMI and use it to manipulate what's going to happen from the PLC perspective? Of course, it's rare to ever find anything like that because they weren't built with those goals in mind. So we need a different approach when we're talking about protection of the OT network. I'll take you through one of the most famous use cases, which is the Petro Rabbi attack from 2017 in Saudi Arabia. This is just a very kind of crude look at what their architecture is over there. They have a very simple Purdue model with their OT network from layer 2 and down, a DMZ there in the middle with a firewall, and layer 3 and 4 and out with a VPN connection. That firewall with the DMZ, it actually turned out, as I mentioned before, not only was it not protection, it became the leverage how the attacker managed to get in. The attacker was able to gain credentials of a VPN, and because he was on the VPN, the firewall recognized him. The firewall said, "Oh, I know you. You're fine. You can come right in." And once he was past that DMZ firewall, he was inside the OT network. They were able to deploy their malware on the workstations of layer 2. They're able to install their code and control the PLCs. And from there, they were able to take down the safety systems on the plant floor itself. And the reason why this attack is so discussed is because that firewall, at the end of the day, became a green light. It became not only, as I mentioned, not only the no protection, but allowed the attacker to come right in. And the attacker, by disabling the safety systems, had the ability to actually harm human life. They had the ability to actually create an explosion by disabling the safety systems and literally kill people that were there. Generally, when we talk about attacks, we think about, shutting down production and things like that. This attack is most famous because the safety systems themselves were actually targeted. People talk about air gaps, of course. You think, well, I have my firewall, my DMZ, I have my air gaps in there. We need to make sure that we are talking about the right terminology. There's a huge difference when we talk about a firewall and we talk about DMZs. We talk about a DMZ with zero routable connectivity or all connectivity being taken away. If we have some routable connectivity, if there is some connectivity there whatsoever at all, then you don't really have a pure DMZ. You don't have a pure air gap. We need to make sure that when we are talking about an air gap, we are not simply putting a networking device on one end and a networking device on the other end, and then saying, because of this kind of physical, mental barrier separation, now I will not have any connectivity. This is absolutely not providing protection. Anytime there is TCP/IP connectivity, it doesn't matter how many hops you need to go through. If a sophisticated attacker is trying to get in, they will be able to get in. They can pivot from one device to another very, very simply. So we need to be very careful when we talk about these types of tools. You talk about gaining budgetary funding for a DMZ from your CEO, and he provides it to you, and then you come back and you say, well, actually, what we need to do now is X, Y, Z. So, well, you told me you put in the air gap. So we need to be very clear on what it is we're trying to accomplish and how we're accomplishing it. I'll take you through one of the most common scenarios that we see in our day-to-day with our power generation customers. It's, I would say, our most popular scenario that we have with our customers, certainly in power generation, is the use of OPC. We have all the DCS, we have the PLC. Generally speaking, there's going to be an OPC server there on the edge of the OT network that's consume its layer 3, maybe layer 3.5, which is generating OPC data, which is then feeding into a historian, which is now talking and being used by the IT and the enterprise side. Again, if we assume that the historian is an OPC client, which is reaching through to the DMZ firewall to the OPC server, so now again, we've created this OPC TCP-based tunnel going through a DMZ firewall. So what are the ways in which an attacker can leverage that for their own attack? Well, if you are understand the basics, which I pretty much only understand the basics, let's say, of OPC, but OPC DA is a Windows-based tool. It's a Windows-based protocol. It requires DCOMs. So if we're using a Windows-based server and we understand the tools that exist there, we can execute our remote code and use that to leverage and gain control of that OPC Windows server. And from there, you can pivot out to the PLCs and to the other controllers inside the OT network. Additionally, you can send in write requests from the outside to the OPC server itself. If you have access to the server, you can send in requests, and that can actually manipulate and destroy data on the OPC server, which would be ruining your business and ruining the data that you are doing for your analysis on the historian side. And finally, just simply based on the DCOMs, if you are running DCOMs through your firewall, you're not left with a firewall. At the end of the day, you're pretty much left with a very large holes and gaps in your firewall, essentially turning it to Swiss cheese, saying that the firewall at this point is not really accomplishing much of anything. So we need to be very, very aware and careful of the tools that we're using in our OT network and accessing them from our IT network and how we are going to provide protection. It's very common that we'll see tools that customers will put in place to make their lives easier from a process side and engineering side will entirely ruin their entire cybersecurity architecture. The waterfall solution to these problems is what we call the unidirectional security gateway. This is providing absolute protection of the OT network. I'll explain to you how it works. From here, maybe I'll talk about one or two use cases, one or two examples that we have, and then I'll be happy to take questions. You have here on the screen, on the left-hand side would be the typical OT network industrial. On the right-hand side, typical IT. Let's assume that everything here in the red box is sitting where the DMZ firewall is sitting essentially today, layer 3.5, give or take. Everything here in the red square is the waterfall technology. It's a combination of hardware and software. The goal here is to take the data from the OT network in a unidirectional manner, bringing it out to the IT network and ensuring that nothing can come back that would harm into the OT network. We want nothing coming into the OT network at all. So the hardware component is the gateway you see here sitting here in the middle. It consists of two important modules, the TX transmission module, which is a laser. We are taking data, sending it down a fiber optic cable, and it's received on a photocell on the IT side. Because there is no laser transmission on the IT side of the device, and there is no receiving module, photocell on the OT side of the device, it is physically impossible for data to come through this device from the IT side to the OT. It is only literally physically possible, based on the laws of physics, for data to pass in a unidirectional manner down the fiber optic cable with a laser and a photocell from the OT side to the IT side, from the TX to the RX. The TX sends data to the RX blindly. There is no TCP/IP communication coming back, acknowledgement to the TX. Instead, we are the proxy from our TX host to the industrial system, creating a bidirectional protocol communication session over here. We are the proxy. We bring that through the gateway in a unidirectional manner, and we recreate that bidirectional session acting as a proxy again on the far side. No attacker. Yes, please.
Elisha, if you can conclude in a minute or two.
No worries. I'll finish with this slide and happy to take any questions. No attacker in the history of the world has ever managed to penetrate and break the laws of physics. So what we are accomplishing here is 100% physical protection of the OT network. Our software is sitting on these host servers, and this is what's giving you access to the industrial systems. So as I mentioned before, if we're talking about OPC, we're talking about a historian, we're talking about a database, Waterfall develops literally hundreds of different software licenses, which give you the ability to pull and take the data from the industrial server on the OT side and create a replica copy of that server for your access and use on the IT side. This is what Waterfall is trying to accomplish, to give you access to the data in real time, but have unidirectional protection of the OT network so that there is never ever going to be an internet-based cyber attack into the OT. Of course, we can talk much more about this topic specifically and cybersecurity in general. I invite anyone that's interested to get in touch with myself or our local partner in India. We'll be happy to continue the discussion, show you a demonstration, arrange for a POC if you're interested, and certainly continue this discussion. So thank you everyone for your attention, and thank you to the Institute here for arranging this entire session today. Thank you.